Hi guys, this video today is going to talk about how to solve a equation with logs that has more than one log or more than one exponential in it. And basically what we have to do then is we have to go back to these log properties that we were studying the other day. So I've reprinted them here. This is just cut out from your textbook. And we need to use those so that we can solve the equations. So we have to combine things, condense things before we can solve it. So in other words, the other day we learned that if there's a plus here, that means we multiply. So I'm going to change this and condense this to a multiplication problem. And so I changed it from a plus to log base 3 of 5x is equal to 2. Now at this point, you can use whatever method you like from the lesson the other day. So we could go left, right, left. We could take 3 to the power on both sides and exponentiate. We've got a variety of things we can do. So I'm going to go ahead and go left, right, left. And so if I go left, right, left, I get 3 to the second. So I get this 3 to this power is equal to 5x. Well, 3 to the second is 9, so 9 equals 5x. If I divide by 5 on each side, I get x equals 9 over 5. And so that's my answer. And so again, the key to this lesson today is just remembering these and working them out. I mentioned a minute ago there's more than one way to do these, and we did this on the other page also. So I just did this with left, right, left, but I could also exponentiate. First, I'm going to put these together, and then once I have them condensed, now I can exponentiate. And what that means is I'm going to take a big 3 and take it to this power on each side. So the power of log base 3 of 5x and the power of 2. So on the left side, the log 3 and the 3 to the power of are inverses, and they cancel each other out, and I'm left with a 5x. On the right side, 3 to the second power is a 9. And again, I'm going to divide by 5, and I get x equals 9 over 5. So I'm just trying to show you once again, there's more than one way to do these problems. Sometimes there's more than one step to combining things, to condensing things. So for instance, remember that if there's a 3 out front, that really means the log of x to the third. And then I have a minus, and a minus means divide, so I'm going to have x to the third over 2. So I get the log of x to the third over 2 is equal to 5. Remember, if there is no base, then it is base 10. That's the common log. So it is base 10. And so once again, I can go left, right, left, or whatever method I want to do it. I'm going to go left, right, left again on this one. So if I go left, right, left, I get 10 to the fifth is equal to x to the third over 2. 10 to the fifth is a 1 with 5 zeros after it. And I have a 2 over here, so I'm going to multiply both sides times 2 to get rid of that fraction. And now I have x to the third, so I'm just going to take the cube root of both sides. I'm going to do that on my calculator. And so I end up getting x is approximately equal to 58.48. Okay, and again, I could do this another way. So again, we could maybe exponentiate. You can only exponentiate or even do left, right, left, though, when you've condensed it down to a single log. So you really do have to condense that down first. And so since I had already done that over here, I just brought that answer over there. So I've got log of x to the third over 2 is equal to 5. If I exponentiate, I'm going to exponentiate with a 10 because this is log base 10. Even though it doesn't say 10, it is log base 10. Log base 10 and 10 are inverses of each other. They cancel. And so that leaves me with an x to the third over 2 on the left-hand side and 10 to the fifth on the right-hand side. And once again, I'll multiply times 2. I'll take the cube root, and I will get that same answer. Okay, the one-to-one property, notice that on the ones up above, the problems up above, we had logs on one side and numbers on the other side. Logs on one side, numbers on the other side. Number 3, we have logs on both sides. And so we need to talk about how are we going to do that. And so the first thing we are going to do is to condense them like we've been doing. And so this one, because it is plus, I change it to a multiplication. So I get log base 3 of 5x equals log base 3 of 2. The one-to-one property says basically that we can cancel those log base 3's out. Technically, to do that, what we could do is we could exponentiate and take that 3 on both sides. And then the 3's cancel off with the log base 3's, and we get 5x is equal to 2, which means that x is equal to 2/5. Now, we can do that with the 3, but what this one-to-one property says is you really don't have to show that work. That's what that's saying is, because these are the log base 3 of the same thing and they are equal to each other, well then don't those two things have to be equal to each other? Or maybe another way to say that is, if you took 2/5 and plug it into here, what would you get? Well, you'd get 2. It's like log base 3 of 2 is going to be log base 3 of 2. They're going to equal each other. However, if we look at number 4, even before I start it, even before I condense it, I can see that something's wrong. Do you see what's wrong? I have a base 3, a base 3, and a base 7. This one is not possible. It's not impossible. It can be solved. We just, in this class, we're not going to get there. So for us, if it does not have a common base, then we're going to skip it. Okay, a couple more examples. This one, they're not the one-to-one property because they don't have a natural log on this side or log on this side. Let's just take a look at what we would do though. What do you think you should do first? Probably combine those, right? And if we condense those, we get 6 over 3x. And now what? This is a natural log. What does natural log mean? Well, for me, I think it's going to be easiest here to exponentiate with an e. So I have e to the power of natural log of 6 over 3x, and I have e to the negative second power. So my e and my ln, natural log, are inverses of each other. They cancel each other out. And e to the negative second power, I can go to my calculator and calculate that. And when I put it into my calculator, I get that it's approximately 0.135. Here's where a lot of people just get stuck on basic algebra, and that is when there's an x in the denominator, people get a little bit confused. I would say let's just follow the rules that we know. If we want to get rid of a denominator, which we do, let's just multiply by 3x over 1. And when we do that, those 3x's are going to cancel, so we get 6 is equal to, on my calculator, 3 times 1.135 comes out to be 0.406. That was actually here I just rounded it off, but here I left it in my calculator. So if you got 0.405, that's fine, but 0.406 is okay too. And that's where my x is. And now I have to divide by 0.406. And so when I do that, I get about 14.78 is approximately equal to x. There are shortcuts, other ways to solve for this x, but I want to stick with what we know mathematically works. So I'm not going to take any shortcuts on there. I want to show you exactly how that works. One way, of course, you can always check these in your calculator is you could plug this number into this x and multiply it times 3, and then take the natural log of it, take the natural log of 6, subtract those two, and they should equal -2. So on each of these, we haven't really talked about checking your answer, but you can always check it by plugging it in. Okay, last problem for today. Oh boy, what do we do here? This is going to be a longer problem. There's a couple different things we could do. There's several different things we could do. Yeah, we've got a variety of options, but I think what I'm going to do first is, do you notice that this is already condensed? That is as condensed as we can go. We only have a single log. And that minus does not mean we're going to change it to divide. It's only when, let me tell you when you would change it to divide. If this was a log base 7 of 2x minus a log base 7 of 3, then we would change it to division. But it's not, is it? It's together there. There's only one log already. If there's only one log there already, we can't put it together anymore. We've already put it together. We've already condensed it. And so since it's already condensed, I think I'm just going to go left, right, left. I'm going to go 7 to the second power is equal to this. Okay, if I have 2x minus 3 to the second power over here, right, I can see a couple different ways to solve this. I'm going to solve it a way that is maybe the longer way, but the reason I'm going to do that is I'm going to show you something that's important. So there is a little shortcut. You could just set this 7 equal to 2x minus 3, kind of like the one-to-one property. Like if this is second power and this is second power and they're equal to each other, we should just be able to set 7 is equal to 2x minus 3. And that does work. And you will get the right answer. I'm going to take the long way so that you can see a situation that might arise, because it won't always be that obvious. So I just want to show you how this is going to work. So on the left-hand side, we know that's 49. On the right-hand side, we're going to have to multiply this out. So we're going to take a second to multiply this out and simplify that and see what we get on the right-hand side. Okay, so on the right-hand side, I get 4x squared minus 12x plus 9. That's what I got from here. Then I'm going to subtract that 49 from both sides, so I get a -40. I need to factor this. But before I factor it, I can tell I have a GCF. So I'm going to take out that GCF to make my factoring a little bit easier. And now I do have to factor it. So we've been doing this all year. I'm looking for the factors of -10, which add up to -3. So that's a -5 and a +2. So it looks like my two answers are x equals 5 and x equals -2. Okay, but if I did it the way I was talking about at the very beginning, and I didn't work it all the way out, and I just set 7 equal to 2x minus 3, what would we get if we did it that way? We would add 3, we would divide by 2, and we get x equals 5. Okay, I do it this way, I get one answer. I do it this way, I get two answers. Which one is right? Well, they both have a 5, so we're thinking the 5 is right for sure. What about that -2? Well, if I plug in that -2 and I work it down, I simplify it, I'm going to stop here for just a minute, because couldn't I rewrite this, because it's a second power, couldn't I rewrite it as 2 times the log base 7 of -7? And so 2 times what is equal to 2? Well, 2 times 1 is equal to 2. Is this 1? It's not. It's -1. In fact, it's not even -1. You can't take the log of a negative number. If you put it in your calculator and try it, it will tell you error. So here I am on my calculator. I'm going to plug in log base 7 of -7, and I get error, non-real answers. In other words, you cannot take the log of a negative number. And we talked about that a little bit, how it's because of that graph. The graph doesn't go to the negatives, right? It only stays in the positives. So that is not possible. And so we've been talking about this throughout the year at various points. This -2 is extraneous. That is, you tried to work it out and it seems like all your math was fine, but it turns out it does not actually work out. And the reason those extraneous solutions come up is usually because there's more than one way to solve it. If you had solved it this way, you would have only gotten the one answer, and it is the right answer. If you solve it this way, you end up with an extraneous solution. Okay, that's it for the video. Take a minute if you have some space to write a summary, and again, the assignments are there on the assignment sheet.